This is Alex. I'll be explaining lab 2, question 6. So, in question 6, we're asked to answer that if the depth of the lake would change. If it changes, would it be rising or falling or neither? If after we throw the cannonballing to the lake, um, we through the little experiment that we did above in the cup, the steel ball bearing in the cup, we know that the depth or the height of the water would go down. So it's safe to assume that same thing will happen, except that the question asks you if would the boat mass matter. I say that it doesn't matter because at the end, the boat has the same mass and same has the same volume of displaced water um, in the lake. So it will cancel out or be subtracted at the end. So what we need to worry about is actually the cannonball. So we first find the volume of cannonball by using m divided by rho. So mass of cannonball divided by density of steel, which is what it's made of. Is equal to 25 kilos divided by 8.05 E3 kilograms per cubic meters is equal to 3.1 E minus 3 cubic meters. Once we know the volume of the cannonball, we can find the volume of the displaced water, because the only thing different is um, these not G will be cancelled out, and it's the only different thing is it's the density. So through a little manipulation through from this equation, rho GV cannonball is equal to rho GV displaced water. We can find the volume of the displaced water. So it's equal to rho density of steel times volume of the cannonball, the whole thing divided by density of the water. Of water. It's universally the same. So we get 2.5 E minus 2 cubic meters. So just like what we did above, we use the difference in the change in volume, which is V2 minus V1 in this case. V2 would be it should be negative sign right here, but V2 would be the volume of this displaced water what we just found, and V1 would be the volume of cannonball right here, 3.1 E minus 3 cubic meters. So the difference between these two divided by the area of the lake, which was given, I believe, in the question, right? So yes, and it came out to be it really should be a negative sign here, but that's the change in height. So it went down 2.8 E minus 4 meters. Um, it's very insignificant as a whole, because the lake is obviously you can't really feel it, but there is a reduced height or depth